Hello children, in this video we are going to learn about projectile motion, angular projection or oblique projection, right? So what is angular projection or oblique projection? You just stand on the plane surface and you are throwing the stone upward. What happens? The stone after flying, it will take a curved path like this, right? This curved path we call it as the trajectory. Now your initial velocity of the projectile, you are giving initial velocity to the projectile is, let it be u. You are resolving u into horizontal and vertical component. Horizontal component is ux, that is u cos theta, and vertical component is u sin theta. Now in this trajectory, OAP is the trajectory. In this trajectory, in whichever point you consider children, this horizontal velocity ux will always remain constant. But this vertical velocity, it will vary, right? This vertical velocity, it will vary. What might be the reason? Got any idea? Yes, because of gravity, the vertical velocity will vary, right? Now, you can see that till this, okay, O to A, vertical velocity is upward. Here vertical velocity is 0, and while the particle is moving downward, you can see the vertical velocity is downward, right? Now you pause the video and you can take down the notes, children. Now if you want to learn this answer thoroughly, you have to first be clear with what and all you are going to derive in this. First you are going to derive equation of projectile motion, maximum height, time of flight and horizontal range. It is always better to you just learn this and then you can go to the derivation part, children. First have an idea what and all you are going to derive in this. So 4 things you are going to derive and note down the headings, and what you are going to use only the 3 Newton's equation of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. These are the 3 basic Newton's equation we are going to involve in this answer, right? We are going to use it in this answer. So again I repeat, it is always better what in which part you are going to use, which Newton's equation of motion you are going to use. You be thorough with that, then you can learn the derivation. If you are thorough with this, you can do the derivation by yourself, right? Now and after that you should be also clear with this. Horizontal component velocity, this is vertical velocity, vertical component of velocity, and the acceleration along x-axis is 0 and acceleration along y-axis it will be minus g. And these 4 things also you must remember to while learning this, while deriving this. Now why this acceleration is negative g? Already we know that because the velocity of the particle you are giving in the upward direction, whereas the gravitational force act in the downward direction. Both are in opposite direction, so g you will always give it as negative. This already we have discussed in the previous video, right? While you know what is meant by what is maximum height, children, you can see in the trajectory path, in the trajectory OA is the maximum height. What will be the range? This is the horizontal distance. OP is the range. O to P, this horizontal distance we call it as the range. Okay, from the point of projection till the projectile hit the ground, this horizontal distance we call it as the range. And you know what is meant by time of flight? That the time taken by the projectile from the instant of projection till the projectile reach the ground. This total time we call it as the time of flight. Okay, now we will go to the derivation part. As I already told you, equation of projectile motion, first you have to discuss motion along horizontal direction. You are using Newton's equation, V is equal to u plus at. Horizontal direction, that means it is along x-axis, right? Before that, you consider this diagram at the point P, right? It is it is the point of projection, and this is the maximum height. In between these two, maximum height and from the ground level, in between these two you consider an intermediate point P. The projectile reaches this point P in time t. Okay, so if with respect to this point P, this will be the horizontal distance x and this will be the vertical distance y. Okay, to this point, horizontal and vertical distance. Okay, coming back here, motion along horizontal direction, v is equal to u plus at. All the v, u, everything should be calculated along x-axis. So v is equal to velocity along x-axis is equal to ux, you can substitute it as u cos theta, and ax is 0, acceleration along x-axis 0. That's what I told you to remember this 4 equation, children. You can see ax is 0 and ux is equal to u cos theta, right? So if you substitute this, you will get Vx is equal to u cos theta. So now at the point P, the horizontal distance you want to calculate. So go to displacement formula, S is equal to ut plus half at square. So the subscript x represent it is along x-axis. So in displacement along x-axis is x is equal to ux, as usual you are substituting u cos theta, and acceleration along x-axis is 0. If you substitute these values, you will get this x is equal to u cos theta t into t. From this, if you take t, you will get x by u cos theta. Now motion along vertical direction. Again you are considering the same Newton's equation, v is equal to u plus at. Along y-axis you are considering, so uy is equal to u sin theta, and ay is equal to negative g, right? Again I say, repeat children, from this ay is equal to negative g. If you substitute these values in this equation, you will get vy is equal to velocity of the projectile, vertical velocity, vy is equal to u sin theta minus gt. So go to the formula, s is equal to ut plus half at square, and sy is equal to displacement along y-axis is y, right? Along vertical displacement is y. So sy will be y and uy will be u sin theta as usual. Ay is minus g, and t is equal to x by u cos theta, already you have derived here. So if you substitute these values in this equation, and if you simplify, you will get y is equal to x tan theta minus half g x square by u square cos square theta. The same thing I have written it again, and you can see that this is the quadratic equation in the form y is equal to bx plus ax square. This is the equation of a parabola. This is in the format, okay, this is in the format of y is equal to ax square plus bx format. So you can say that the equation is a projectile takes a parabolic path, right? So next we are going to derive maximum height, formula for maximum height. So already you know maximum vertical distance traveled by the projectile during its journey. For that, as already we have discussed, you have to remember, you are going to use this formula, v square is equal to u square plus 2as formula, and if you substitute vy is equal to 0, uy is equal to u sin theta, and ay is equal to minus g, s is equal to h maximum height. Substitute these values in this equation and you will get h maximum is equal to u square sin square theta by 2g, right? The simplification will be very easy. This formula you have to memorize. It might be a 2-mark problem, right? Using this formula you might have to work out a problem. So time of flight, total time taken by the projectile from the instant of projection to the time the projectile hits the ground. So to calculate time of flight, you consider Newton's equation. So displacement along y-axis, velocity, initial velocity along y-axis. So if you substitute this value here, displacement along y-axis at the time of flight, it is reaching the ground, right? The projectile is reaching the ground. It is reaching the ground. So there is no vertical displacement in this case. So sy you will write it as 0. uy initial vertical velocity is always u sin theta. This will be always minus g, and t is the time of flight, right? So if you substitute these values in this equation, you will get time of flight is equal to 2u sin theta by g. And finally, you are calculating horizontal range. Horizontal range, that is the horizontal distance between the point of projection to the point where the projectile hits the ground. As already we have discussed, horizontal range, distance is velocity into time. Distance is horizontal range is represented by r. Range is nothing but distance. So distance is nothing but range, that is equal to velocity, horizontal component of velocity into time of flight. So here horizontal component of velocity into time of flight. Horizontal component is u cos theta, and time of flight already 2u sin theta by g, you know, right? So you will, what will you get? U square 2 sin theta cos theta by g. So you already trigonometric relation 2 sin theta cos theta is nothing but sin to theta. So r is equal to u square sin 2 theta by g. Now in this case, when the range will be maximum, when the projectile will go to will fall in the far off distance. For that, if you substitute theta as 45 degree, you will get 2 into 45, sin 90 is 1. So r will be u square by g, it is the maximum range. If theta is 45 degree, what I mean is, if this angle, if projectile, if it is projected at an angle of 45 degree, this stone, it will fall on the far off place, right children? So remember this, theta is 45 degree, range will be maximum. Okay, thank you children. This might be a 5-mark question. Each and every formula is important to work out the numerical problem, right? Range, u square sin square 2 theta by g, time of flight 2u sin theta by g, and maximum height u square sin square theta by 2g.